for new patients based on clinical features and symptom evolution over time.
We present an investigation into design judgment in data viz practice. Our findings show how different types of judgments influence design decision-making. Our findings also show that judgments occur in complex and layered ways while designers move through their process. We discuss implications for future research and pedagogy.
Dimensionality reduction is an important tool for the visual exploration of complex high-dimensional data. Most existing techniques focus on preserving the intrinsic geometry of the data during the projection. However, important informations can be encoded within the global structure of the data. To address this, we present TopoMap, a dimensionality reduction method that provably preserves the topological features of the data during the projection.
This work presents a detailed account of an attempt to explain tightly coupled relationships through storytelling and animation in a multi-user, informal learning environment to a public with varying prior knowledge on the domain and identifies lessons for future design. It offers qualitative empirical findings with particular emphasis on how, despite careful design, visitors may walk away with little knowledge about the data and the problem.
The blood vessel structure on the human placenta can be an important indicator in the detection of birth complications, but the segmentation of the vasculature tree remains a challenging problem. In our work, we show how MRI visualizations in immersive virtual reality can help medical practitioners to identify blood vessels without the need for a contrast agent. We present the results of a user study and lessons we learned for vasculature exploration in VR.
Hello, my name is Bryan. I'm the session chair for the short papers session that we're starting right now. I'm an assistant professor at Arizona State, and we're going to start off this session with 3 papers, 1 position paper and 2 short papers. So this year at VizSec, we introduced a new paper type, position papers, focusing on topics that really need discussion or more awareness in the VizSec community. So we have one position paper this year, a visualization for spectators in cybersecurity competitions, and it will be presented by David Schwartz.
Welcome to our talk, Visualization for Spectators in Cybersecurity Competitions. My name is Dave Schwartz, and I'm the director for RIT School of Interactive Games and Media. Thank you for taking the time to watch this presentation. First, I'll give an overview. In this talk, we'll briefly review various issues we've sought to address in cybersecurity competitions, starting with something called the CPTC at RIT. The CPTC shares a common problem seen in other competitions, needing improved visuals, and in many cases, any visuals. We're using this talk to expand on the paper with respect to games, and we'll follow with some examples of past and current work. We're especially interested in leveraging the field of esports, which has been foundational for our work in improving the spectator experience. Our main goal is to improve the learning that happens in cybersecurity competitions through visualization and other engagement. So, we can start by modifying an old adage to be, a picture says 1,000 words. If you're curious, you've probably also noticed my discovery of PowerPoint's built-in 3D models, which were added in the 2016 edition. See how many you can find in this count. A game. Anyway, after we learned how to make pictures, we started moving them. Computers appeared, and then we wanted to interact with these images and animations. And as computers became more omnipresent, we forged a universe of digital games. As game research has burgeoned, we've given games and other interactive experiences a sense of purpose to forge the concept of gamification. Gamification boils down to thinking of interactive experiences as games, or embedding a core experience as a game. For the purpose of this talk, we're looking at serious games, to make serious experiences fun and engaging. Actually, many here probably run or participate in a form of serious games already. The following concepts should seem very familiar. We have hackathons and jams, which have been replacing traditional career fairs, though probably on pause for now. In my field of games, our game jams are short-term events in which game or interactive design teams create experiences pretty much on the fly. It's been interesting to see more collaboration, especially when incorporating the idea that there's this meta competition happening if career networking is going on. When I was first approached to consider this research, I hadn't known how cybersecurity education might adapt to hackathon. And sure enough, there's definitely a parallel that's been happening. If I were to make an elevator pitch for cybersecurity education, I'd distill the idea into a one-liner. It's a good exercise. If you can sell an idea in one pithy line, you're probably onto something. In this case, we came up with this one. Competition is intrinsic to the pedagogy of computing security education. I repeat, competition is intrinsic to the pedagogy of computing security education. And sure enough, RIT has had one of the main contenders in this arena. The Collegiate Penetration Testing Competition, or CPTC, started at RIT in 2015. It's become a rather massive event, involves a lot of schools and external support. I grabbed from their description this quote: "Instead of defending your network, searching for flags, or claiming ownership of systems, CPTC focuses on mimicking the activities performed during a real-world penetration testing engagement conducted by companies, professional services firms, and internal security departments around the world." Actually, there are a lot of competitions out there. One of the things we're still researching is what we call a market analysis. It's essentially the background research, and we're trying to capture the common elements across these competitions. For example, what distinguishes one game from another? What's done especially well? Actually, being versed in the game world can help with this kind of work. We are still dealing with games. I think it helps to understand the root of competition through the lens of games. The roots of game design pedagogy are essentially the roots of cybersecurity competitions. A competition with rules, points, goals, challenges, and scores forms a game. For those looking for a starting point, Rules of Play does an excellent job summarizing many thoughts on the nature of games. For our purposes, we think of a game as a series of interesting choices that yield outcomes. In a competition, we have players making decisions with consequences, striving to yield the best outcomes. From there, it helps to dive down into more terminology. We distill some concepts as follows. Gameplay is what the player experiences. Game mechanics are what the players do. And yes, they're intertwined. We can even classify games with the genres based on gameplay. So thinking about cyber, some here may have already been using some common terms. Our current team has been modeling Capture the Flag and King of the Hill. These genres seem to form the basis of many cybersecurity competitions. I thought we could use this talk to dig a bit deeper into the roots of competition, especially as it will explain why visualization and production are worth additional research. Games of strategy stretch back to early modeling and simulation for military conflict. If you've never done much with war games, you might be surprised at one of the progenitors, H.G. Wells' and Little Wars. The modern practice of tabletop exercises helps with situational and/or disaster preparedness, and itself stretches back to war games. The games themselves offer deep engagement and have continued to be used by the military and government, especially as visual and interactive learning and training experiences. So where are the visuals for cybersecurity competitions? I've been obsessed with painting lately, especially since I'm here most of the time. As I'm doing this recording, the wall to my left is that picture on the left, and to my right on the slide, and about 50 feet away from me, is the new garage floor. If you're asking why I'm talking about paint, sure enough, the Wall Street Journal and others have noted that witnessing a cybersecurity competition is akin to watching paint dry. A while ago, the CPTC developers realized that despite the excitement felt by the players, the spectators were usually wondering what on earth was going on. So we realized we could join forces and do better. The original goal of providing more engagement for the CPTC has inspired quite a bit of design, and we can show some early concepts in this talk that extend beyond the paper. We're still working on the interfaces, accessibility, and the core mechanics. Some of the inspiration for these images are the scoring systems. By the time you see this talk, the work will have progressed further, but we thought it would be interesting to see what some game students could do initially. Next, I give another early example. This is a King of the Hill mock-up and proposed architecture. CPTC doesn't use the hill, but the team was curious how we might display competitor progress for the genre. Again, accessibility is still an issue, and so it just gives a taste of what's to come. Extending this idea further, we have a racing interface. This one came from thinking about red versus blue mechanics, perhaps across multiple teams. Sometimes programmer art works really well. We also see using school or team logos, which gets into the idea of esports discussed later. If anyone wants the stick people for their competitions, just let us know. In terms of what we currently have, we have some prior visualization in the form of the Pwn board. There's some branching in Git if you're curious. You may see, well, some salty comments, and so I leave it up to your discretion. Interestingly, much of this visual work tends to focus on distilling scoring into a more coherent form, at least to provide some form of visualization to the full audience. The CPTC is kind of catching up now compared to related work. For example, the CTF work linked here has this quote, "Unfortunately, for the CTF audience, even one dominated by the technically savvy, viewing these activities is about as engaging as watching small groups of students work on challenging homework problems. At least they're not watching paint dry." The second project, Lucid, is an established NSF-funded project that is building animated avatars for spectator engagement. I refer everyone to that work to see the visuals and the current progress. Right now, we're more interested in live MCs, which we address later in the talk. We can connect all of these ideas by thinking about the spectator experience. From my perspective in teaching game design and development, we focus so much on making games for the players, we often forget who might want to watch the players, as Twitch and other streaming services have demonstrated. So, if you're running your own competitions, we now wonder who could be or should be watching. There are prospective students, parents, siblings, grandparents. Not everyone is going to have the same level of expertise. They may have no expertise. Maybe it's even enough to abstract an entire competition down to a visual tug-of-war or Godzilla versus Mothra. We may want to inspire greater diversity in computing security, teach an audience about self-defense, and corporate sponsors might have testing, career networking, and other goals in mind. So now we have yet another challenge. First, we need to learn about who could be and should be watching. From there, do we need something as simple as the Pwn board? Or maybe we need, all we need is Sharky versus Robolord from a couple slides ago. We need to balance the demands for people in and around the competitions. Think back to tabletop exercises. We need to simulate something that the designers seek to test, model, and teach. We probably want the opportunity to draw more people into the fold, especially given the importance of cybersecurity in our lives. Say we focus solely on the spectators. Are we shortchanging the original goals to teach competitors about the intensities and complexities faced in the cybersecurity world? In response, we advocate for a more advanced design of the competitions to incorporate spectator needs. In the paper, we provide our initial architecture, which we summarize in the rest of this talk. As I mentioned before, our game students are focusing on the CPTC as a starting point for learning how to improve visualizations in the spectator experience. We suspect that the core components of the architecture will remain similar. Let's start with the core engine. One of the key selling points I've pitched to my game students is my own one-liner. Can we build the Unity or Unreal for cybersecurity competitions? If we can do enough comparative analysis, there's an amazing opportunity to help the world of cybersecurity simply by making better game design tools. Add in machine learning and advanced analytics, this engine would likely extend not just into the game and spectator experience, but into improving the pedagogy incorporated into the competitions themselves. Go meta! With regard to the spectators, if an overriding goal for a competition is to provide a robust learning experience for all designers, competitors, and spectators, then we need mechanisms for viewing the teams without interfering with the competition itself. Setting up cams at each station, or even having a camera crew provides a multitude of streams. We also see a hint of production values, event management, perhaps even VR for deep immersion. The complexity of connecting with multiple data streams, the game, the crews, and more aspects shows the need for another kind of engine. Each output from the streams, the game, the announcers, the game masters, and so forth requires integration through an event system or production processor. In fact, we want to keep dissecting related competitions to find ways to encapsulate these streams into a generalized framework to reduce the development time for separate productions. We're in the midst of doing what's called a vertical slice for the CPTC to test the production software, especially to show the visualizations and incorporate the feeds from competitors and casters. And literally, speaking of casting, now we consider sports casting. We've seen this kind of role in a number of events. Even war games and tabletop exercises have game masters and use subject matter experts, SMEs, to help design the games. Since we want to have casters be extremely knowledgeable about the cybersecurity competitions, we probably aren't going to call them SMEs, but that's essentially the idea. At least, not cruise directors. The casters now explain things to the audience, which means we need visuals. One could make the case that with fleshed out game engines, we could leverage the entire field of cyber visualization for the different kinds of spectators. Long ago in grad school, I remember seeing the Doom OS. One would go around killing processes with a variety of kill-9 guns. Not that we need more violence, but I can imagine other visual metaphors of doors, keys, fences, and more. We have all these well-established game genres. They could assist with making everything much more appealing without removing core pedagogy, which ties back to the principles of gamification and serious games. From here, esports is the one ring that binds these concepts. At RIT, we started esports teams and competitions a few years ago, and pleased to say we've done really well winning various championships. Along the way, we realized that all the intensity of students banging away at their computers seemed extremely familiar. We're not alone. Wicket 6 gives their elevator pitch as cybersecurity meets esports with a cause. The field of esports gives a full suite of tools and production values that could greatly enhance cybersecurity competitions. Want to go crazier? You'll see researchers asking how League of Legends can influence us even further. So we see an incredible potential. Through this work, there is a roadmap to enhance cybersecurity competitions with production values, engaging gameplay, and spectator excitement with visualization. We believe that the variety of related work and an ongoing progress has demonstrated the potential of esportsifying these competitions. We look forward to seeing this development continue. We thank the current group of RT students who have helped tremendously with this presentation, and we are grateful for our sponsors and those who have provided guidance and continue to help us. Thank you again for watching this talk.
Okay, so if you have questions, please post them in the Discord. We're monitoring that. While we're waiting for some of those to come in.
Thank you for the applause.
So David, I have a question while we're waiting. So, there's lots of different types of competitions that are out there. In your mind, what types of maybe customization could you see for these different types of CTF games?
Yeah, sometimes I worry that a genre gets so played out, people get bored. When we teach game design, if there are any game designers out there or people who teach game design, we're always asking students, do something new, add a twist to it, to say, capture 2 hills, perhaps. Or what does it mean if you go backwards or undo, just throw out sort of random mechanics just to see if it makes it interesting, or take the other approach. If you're going to do a well-established genre, do it really well, be really polished. In fact, we were just talking in my team meeting just before this. I had to make sure I got my team meeting in there for a co-op. So anyway, and one of the things that we've talked about is getting a game design, get a student or perhaps professional game designer involved from the design of the competition from day one. Don't shoehorn accessibility after the fact. Don't shoehorn games after the fact. Put it there at the beginning, because that person would probably bring in that novelty.
Okay. So a question that just came in from Steve Gomez. Do you believe there are enough intermediate wins to keep cyber teams engaged in a gamified setting? So do teams need feedback to feel like they're making progress along the way?
Yes. In fact, I think the culture of the cybersecurity competitions themselves, I think it's just, in fact, I look over there with envy that I see this richness in the field that maybe other fields don't have. So I think initially, just the excitement, aha, I won, or I achieved this thing. What we worry about, though, is that, yeah, the scores, like, what do these points even mean? So at least there is some feedback coming. So rather than resting on the laurels and assuming it's always going to be super exciting, this may get boring at some point. Just keep moving ahead. So yes, but do more.
Okay. So another question I had watching your talk. So how do you balance maybe between creating, say, engaging visualizations or maybe dashboards, as opposed to dashboards that might provide all of the analytical information that, there's kind of this spectrum, right? How do you balance the spectrum, or do you go toward one end of it?
We've been having this conversation week after week. I'm beginning to realize what we needed from the beginning was an event-driven system. Just publish, subscribe, build it around an event-driven system. Then the designers of the game say, here's what's important, here's what's less important. In fact, I was just telling the students, implement a priority queue. In a weird way, I think we're watching a priority queue visualization. On the CPT side, we have the college, we realized capture the flag, king of the hill. In some ways, we need more sense of penetration. So visualizing an acyclic graph. It was almost bringing Dijkstra's algorithm to life.
Yeah.
And then, if we were able to attach how important is this thing that happened here, where now we need the security expert to say, nah, it's irrelevant. No, wait a minute, that was critical. And then JSON file, read that in and adjust what's visible there. Then this is where the Unity and Unreal of game design comes in, that the designer of the spectator experience can go, let's skin it. Let's abstract this away to say something big happened, something small happened. And there we actually now need testing to see, well, what kinds of spectators are out there? How long are the competitions? And so forth.
Okay, yeah, makes a lot of sense. Okay, so I think at this point, if you have further questions or want to chat about David's talk, we can use Discord for that. And
thank you, Chris. Thanks, everybody.
Okay, so our next talk will be our first short paper. And the title of this paper is Malware versus Anti-Malware Battle. Gotta evade them all. And it'll be presented by Emily Chaffey.
Hello and welcome. Hello and welcome to our presentation. My name is Emily Chaffey from Royal Holloway, University of London, and today I will introduce you to Goto Evadem All, a system which visualizes the battle between a submitted malware sample and an anti-malware system. Our presentation will follow the agenda shown on screen. We will be briefly covering the background of our paper, followed by a delve into the Goto Evadem All system. Then, we will begin to wrap the presentation up with our discussion, conclusion, and finally answer any questions. The landscape of malware development is ever-changing, creating a constant catch-up contest between the defenders and the adversaries. One could say that malware developers want to be the very best, like no one ever was. The amount of new malware samples released every day requires cybersecurity analysts to resort to an automated process to analyze malware relying on the virtue of isolated test environments, referred to as sandboxes. Although using a sandbox speeds up the analysis of malware, it also introduces additional weaknesses, as the malware may attempt to detect that it is being analyzed in a sandbox, and, if so, it behaves benignly, the so-called sandbox evasion. This might result in the misclassification of the sample, and a potentially harmful program could be allowed to execute. Sandbox evasion can be done via fingerprinting the system by analysing sandbox artifacts, such as registry keys, loaded libraries, and so on, the discrepancy in time between a real and virtual system, and performing reverse Turing tests. Reverse Turing tests are also employed in some malware samples, and we expect this trend to significantly increase in the near future, given it is hard for anti-malware systems to cope with it. We believe that future malware could use a combination of these features and feed them into an embedded machine learning algorithm to determine whether the malware is running on a real host or not. Similarly, the anti-malware system can detect whether the malware is using evasive techniques or not. In this context, reverse Turing tests could be used by malware to determine whether the user input is made by a human or simulated by another machine. By using the theory of reverse Turing tests, an adversary can enhance their malware to be able to determine whether it is running in a sandbox. The malware can then act benign if it is suspicious that it is being evaluated by an anti-malware system. There are many tests that the malware could use, including analysing mouse movement and other properties such as clicks and movement speed. Additionally, more advanced tests could consist of scrolling detection and using captures. In this work, we advocate the use of visualization techniques to help security researchers identify evasive issues in a clear and engaging way, in addition to the standard manual or automated program analysis techniques. We will now discuss how the idea of a evasive visualization system originates from Pokemon. Pokemon may seem a little out of place with regards to malware evasion. However, from a visualization perspective, the games provide a very clear and simple concept to the viewer as to what is occurring. The use of different option screens allow players to choose their next move. On the left-hand figure, we can see the fight and run features, and the figure on the right, we can see examples of different attack moves. Using the fight and run features as inspiration, there was potential for a similarly styled option for a visualization system that displays the choices made by the malware evasion system using animations. We will now delve into the Goto Evadem All system. Our goals were to create a tool which could be used to automatically submit a malware sample to an anti-malware system for analysis, and then visualize in a familiar format of a Pokemon-style battle. We also wanted to emphasize the alternative methods future malware could use in order to evade detection, such as reverse Turing tests. Our system consists of 7 main components: the user, the controller, an Ubuntu virtual machine, a Windows 7 virtual machine, a parser engine, the visualization software, and the machine learning classifier comparison system. The system is run by the user, such as a security researcher or an educator. This leads to the controller starting. The controller then opens the VirtualBox Ubuntu virtual machine, which submits the malware sample to the Cuckoo Sandbox system, which analyzes a sample in a Windows 7 virtual machine. The report of the analysis is then sent back to the Ubuntu virtual machine and then transferred to the parser engine. The parser engine then scrapes the report for the data needed for the visualization system. The system optionally compares the predictions of different machine learning algorithms based on the evasive features the malware exhibits. The classification results are then displayed in a user-friendly way. The visualization system then displays the animation of the battle to the user. The visualization screen shows different aspects of the battle. The first screen is the start screen. This is where the user can click on the screen to begin the animation of the battle. There are two purposes for this screen. The first is to give the user control over when the animation starts, and the second is to give the animation more of a game feel. The next screen shows the malware choice screen. This is where the malware can decide whether to act benignly or act maliciously, where acting benignly results in the malware taking actions to not alert the anti-malware system of its presence. A red box appears to show the malware's selection. The animation then proceeds to show the move the malware has decided to use. It then displays the icon associated with the signature of the move. This is to provide a more visual explanation of the signature. For example, the move on the screen, suspicious TLD, is shown using a globe to represent the internet, and the caption .com and .org represent the top-level domains. On the left-hand side of the screen, there are two more examples of icons that are used to represent categories of signatures. The animation then continues to the anti-malware system's turn. The move detect is then selected, represented by the red box. It then advances to displaying the anti-malware system's move. The move detect represents the anti-malware system analysing the malware sample and coming to a conclusion. It then informs the user whether the anti-malware system successfully detected the malware's most recent move. The battle then continues, and once all of the malware's moves have occurred, the winner screen is then displayed. If the malware has successfully evaded detection, the malware's icon is displayed. Otherwise, the victor of the battle is the anti-malware system, and its shield icon is displayed. This short clip shows a snippet of the visualization aspect of the Godot Evade Them All system. It begins with the encounter between the malware and the anti-malware system. The battle then proceeds where the malware attempts to perform a move, described as a signature. Each category of moves has an associated icon to help users with less knowledge of malware signatures further understand what is occurring. If the anti-malware system detects all of the moves the malware has made, then it has won the battle. The victor of the battle is displayed on the final screen. We will now proceed into the discussion part of this presentation. Malware is constantly developing. This means that checking for evasive malware is very hard, making it more difficult for an anti-malware system to decide how to react accordingly. One could compare it to an arms race game, such as chess. We believe that by visualizing what the malware is doing, we can help security researchers notice evasive behavior more intuitively. This will enable them to come up with anti-evasive countermoves, either in real time or programmatically encoded in the anti-malware system, that can be difficult to engineer without such a visual perspective. The Godot Evade Them All system is a useful tool to educate and explain how an anti-malware system can detect signatures and behaviors of a submitted malware sample. The tool is primarily aimed at security analysts due to its automation capabilities. Furthermore, the visualization aspects of the tool can be used to inform individuals who have less understanding of the cybersecurity aspects. In an education setting, a knowledgeable instructor could use this as a teaching aid. By using a familiar concept based on Pokemon, the proposed system allows the understanding of malware behavior to be more accessible to a younger audience. The system can similarly be extended to be used in cybersecurity competitions such as Capture the Flag events to display the status of an ongoing battle. Currently, the game is fully automated, meaning the system passes the Cuckoo JSON report file and acts accordingly for both sides, as all moves are already recorded. However, in the future, we believe such a system could potentially be used by a security analyst to instruct the anti-malware system on how to react in real time, especially in cases of advanced malware, where the anti-malware system might not be sufficient to fool the malware. Although this would only work for a few cases such as advanced persistent threats, otherwise the system would not scale. In summary, we have created a system which can provide individuals with the foundation of an understanding of how an anti-malware system functions, as well as highlighting the potential areas an adversary could exploit. The Godot Evade Them All system provides security analysts with a tool to aid research due to its automation capabilities for submitting a malware sample for evasion analysis. Additionally, the system makes the concept of malware and anti-malware systems more accessible to those with less knowledge in those areas. Furthermore, it acts as an education tool which displays the steps taken for analysis and evasion in an abstracted and recognizable format of a battle. It also uses simple to understand concepts to enable users to conclude whether evasion was successful or not. Finally, if you would like to find out more about our research, you can check out our paper, and if you would like to have a look at the Goto Evade All system, you can find our GitHub repository at the link on the screen. Thank you for watching.
Okay, so thank you, Emily. That's really interesting. I love these sorts of creative ideas. So again, you feel free to post questions in the Discord. We're looking at that. So the first question that came in here from Marco Angelini, do you plan to investigate additional features of the battle that can be used maybe to communicate technical details or events and potentially improve the explanation?
Yeah, there's definitely a lot of scope for improving the system, and particularly with expanding the viewer's concept of what's actually going on. So it's more kind of like a early stage of development, and yeah, there's definitely loads of scope for improving and becoming more clear.
Okay. Yeah, and this was asked as it's kind of a follow-up question. You kind of talked about it on your discussion slide, but maybe you can expand on it a little bit more. In the prior talk, David was talking about, for CTF competitions, and could this approach, right, this really gamified, I mean, it looks like a game. How could you see it be integrated perhaps into more broader, like capture the flag type of domains?
Yeah, so our concept was that it could be in a capture the flag circumstance, like what David's touched on, is that you'd be able to have, say, an audience watching and they could see the battle going on. And then, so as each round would go on, say, as in like Pokemon happens with each battle, whether there'd be a victor or not. So you'd see all the teams working together. And so say they could be represented by the malware, for instance, and then whoever wins the battle first is the victor of the capture the flag.
Okay. And so just so one last question, right? So currently you're focusing on evasive features, correct?
Yeah.
Yeah. So I mean, why not more generic, maybe malware operations?
Sure. So we're mainly focusing on evasive, like you said, but it's because evasive seems to have a easier to transfer aspects for moves. So with evasive, it could be like detect if I'm working in a sandbox, rather as for generic moves, like one's not coming to me at the moment, but like more generic moves, it's a lot harder to kind of convert into a move that you could create an animation for. So we picked things like evade sandbox detection or detecting mouse clicks and stuff like that, because that is something that is very easy to animate and become a move that is available. But we can definitely look into that if that's something that is there.
Okay, great. So there's some nice comments in the Discord, so we can continue that discussion there. So thank you, Emily. And I think we'll be moving on to the next talk.
Okay, thank you.
Our last short paper, our second short paper that will be presented, our third paper, our second short paper that we're going to present in this session is titled Interpretable Visualizations of Deep Neural Networks for Domain Generation Algorithm Detection. And it will be presented by Franziska Becker.
Hello everyone, I'm Franziska and today I represent the current state of our work to you. We developed a visual analytics tool to let designers of deep learning models examine patterns inside the different layers of neural networks that were trained to perform multi-class classification for the detection of domain generation algorithms. First I'll explain our application case and related work in associated fields. Domain generation algorithms are used by malware to communicate with a command and control server. The DGA produces a large number of domains and queries the DNS server for their address. The command and control server knows the DGA, but only registered some domains in advance, which are then used by the malware to connect to the server and receive new commands. DGAs can generate many new domains on short notice, which makes them more effective than fixed IP addresses or domains, which can easily be blacklisted. Machine learning models for the binary case of malicious versus benign have already achieved state-of-the-art performance. However, the multi-class case encompassing up to 91 different DGAs is more challenging, especially when no additional context information is fed to the model. Recently, deep learning models have been developed to successfully perform such multi-class classification using only the domains as input, and these models are what we use for our visualization. Related work spans across different fields, from artificial intelligence to visualization research. The field of explainable artificial intelligence aims to make machine learning models more interpretable. Prominent methods developed in this field are feature visualization and attribution. Here you can see an example for feature visualization for a CNN by Walrond colleagues. This method uses optimization to visualize how convolutional filters react to a specific image. In visualization research, Rauber and colleagues have developed a system similar to ours. They calculate a 2D projection of the activation data of a model, but are limited to fully connected layers. In addition, they do not explore patterns in the activations except for those found in the 2D projection. In connection to cybersecurity, Norton provides an interactive web tool to explore adversarial examples and compare different methods to generate such examples. It helps the user to find weaknesses of a model, but does not try to provide interpretations for classifications. Next, I'll explain the design ideas behind our solution and show an exemplary use case of our system. We formulated 3 design goals based on previous work and informal talks with a domain expert. First, we wanted the system to be able to visualize different types of deep learning models, since we have different types of deep learning models at our disposal. We achieved this by focusing on the activation data, which is present for any kind of deep learning model. Second, we wanted to explain patterns at the different layers of the model find. To accomplish this goal, we cluster the high-dimensional activations and explain them using a decision tree, which is trained to predict the clustering result. Lastly, the system should provide an overview of the dataset and model performance. This is necessary to help the user get an idea of the data and make a meaningful selection to be used for analysis. We realize this by showing the user per-class attributes of the data and providing a flexible selection interface. Now let me show you an example where we investigate class confusion in our visual analytics system. What you see here is an overview visualization that displays the attribute distributions for the different classes. Each row is a class and has the columns prediction, length, and character frequency. This way the user can see where there might be class confusion and how well different classes are represented in the dataset. For example, you can see that the ChiNet and the cheer class are confused because all cheer instances are predicted to be ChiNet. Something similar is the case for the Gypsy class, which is down here, which is also confused with the ChiNet class. We can select these 3 classes using either brushing mechanisms or the more fine-tunable selection interface on the right. After we defined our selection, we turn to the analysis view, where we can investigate the activations of the different model layers. On the left, you can see the classes contained in our selection, and on the right are the different visualizations. First, there's a scatter plot of the UMAP projected activation data with density contours in the back. Each dot is an instance in our selection, drawn as a circle if it's correctly predicted, and drawn as a triangle otherwise. The activations are clustered using HDB scan, and their cluster membership is indicated by their color, whereas the size encodes the magnitude of its activation vector. The density contours are drawn for each class, making it visible how classes and clusters relate to each other. This is further supported by the top middle view, which shows per-class cluster distributions. On the far right, you can see the decision tree calculated for the clustering result. It uses common text and domain features from other work, and is displayed as an icicle plot. In the bottom middle is a connector between the scatter plot and the decision tree. It's a Voronoi diagram of the projection where the Voronoi cells are colored according to the currently selected decision tree level. The latter can be switched by clicking on the level label, and we can also highlight individual nodes of the tree by clicking on them. We can see that the CNN doesn't find much in this first layer, so we look at some of the later layers. The first convolutional layer sees 3 clusters in total that can primarily be separated using length, and there's visible overlap between all 3 classes. Interestingly, in the second convolutional layer, we only have 2 clusters, which are concentrated on the 2 smaller classes, Gypsy and Cheer. These can be primarily separated using the number ratio, then the top-level domain, and the length. In the penultimate layer, we see 2 clusters, one with the 2 smaller classes and one with the large class, which are separated using the number ratio again. However, this separation does not carry over into the last layer. Instead, here we can see the following. First, we have a lot of instances that cannot be assigned to a cluster, those are the black ones. Second, we also see that there are many smaller clusters inside the China class. However, these clusters cannot be explained using the decision tree, which only separates some of the purple cluster instances. This indicates that more sophisticated features are required in order to separate these clusters. When we consider the same selection in a different model, namely a recurrent network, we see that the Cheer class is not subsumed by the China class, but instead that the Gypsy class is overshadowed by the Cheer class. Looking at the first layer, we see a similar projection clustering to the CNN, although the 2 clusters are not explained by the decision tree, only partially. However, in the next layer, the long short-term memory layer, we see very different results to the CNN. We can see many clearly separated clusters inside the China class, and we can see that these can be separated using only the top-level domain, as can be seen in the decision tree. The instances of Cheer and Gypsy with the same top-level domain overlap with one another, but not with the China class, as was the case for the other model. When we look at the next layer, we see that this pretty much keeps the same separation and the same clusters. The final layer reflects the model's decision, showing 1 big cluster for all China instances and 2 for the other classes, with the Gypsy class being overshadowed by the Cheer class. Let me summarize our system and how it accomplishes our design goals. We show the user a histogram matrix to provide an overview of per-class data attributes and let the user find a suitable selection for analysis. The UMAP projected scatterplot with density contours visualizes the data, whereas the HDB scan clustering shows pattern inside the model's activations. The decision tree then allows for interpretation of these clusters, which is facilitated by the connected Voronoi diagram. A limitation we currently see is that there is no direct correspondence between the model and the decision tree. This means that we may be able to provide an explanation for the patterns the layer sees, but we cannot make any statements whether the explanation is actually the one the model uses. This can be problematic when there are explanations with equal merit or when we try to find bias that correlates with other features in the data. Another limitation concerns the meaningfulness of the clustering, which seems to work well for our data but requires a more thorough analysis. In particular, it would be interesting to see whether these results transfer to other application cases. In this work, we contribute a new XAI system that works for data with hard-to-understand semantics, which provides a layer-wise visualization of custom-selected data subsets. For each layer, we present the user with a clearly formulated interpretation of patterns inside the model's activations. Finally, in future work, we would like to perform an in-depth user study to test the utility and usability of our system. We think that an interesting direction to extend our system is to be able to add new samples or features. This would allow the user to explore adversarial examples and find out where higher-level features were learned. We can also envision our system to be used to test features to construct feature-based classifiers with better performance. This concludes my talk. Thank you very much for your attention.
Okay, thanks for that talk, Franziska. Again, you can post questions in the Discord chat or wash hand emojis, and we're monitoring that. So, so one question, you mentioned this on your future work. You haven't yet done a user study, an empirical evaluation with your target users yet. So what are the kind of the important aspects maybe to consider for types of, for visualizations in this explainable AI field?
Yeah, I think, of course, an evaluation is what we're hoping to do next. Utility is always one thing in visualization. You want to look and see how well that your target users can use your tool, but I think especially in XAI visualizations, what's also important is how the visualization affects the perceived explanation, so that you can measure how maybe misleading your explanations are. For example, how misleading can the features be? And I think that's particularly hard, especially when you don't really have a ground truth. You're trying to get an explanation from the visualization, but you also have to evaluate how good is it actually. I think that's hard to design a study that really does that well, but I think that's also a very important thing to do for these types of visualizations.
Okay. So we have a question from the Discord from Leo at Graphistry. So these visuals seem tuned for data scientists. So any thoughts on making like the UMAP and other designs more accessible maybe to regular analysts?
Yeah, actually, we started out also wanting to have this kind of visualization for cybersecurity experts that maybe have to work with DJs and have to assess the output of a model. But I think, so that's definitely something we've been thinking about. Although right now I think it's too detailed and too focused on the model aspect. But I think definitely with like abstracting away a bit there and providing more clear-cut possible explanations for how the model behaves, this could also be something useful for other analysts that are not that deep into data science or machine learning.
Okay, so do you have like maybe like considerations on specific ways you could maybe extend the system or tailor it more for, say, cybersecurity experts?
One thing we definitely want to do that I think that's beneficial for both machine learning or model developers and cybersecurity experts is to provide more interaction means, so as to probe for new samples, because I think that's probably what the cybersecurity analysts want to do, but also try to get an even more holistic view of how the model reacts to some things and have it not be as detailed going into the layers one by one, and also making it easier to start out and not having to get an idea of the whole data set first, because it's probably not what you're interested in if you're a cybersecurity expert.
Okay. Okay, and one last question from Steve Gomez just came in on Discord. Have you thought about meaningful ways to gauge how much machine learning target users had? So what, and that could help you decide whether the representations are going to be appropriate.
Yeah, we have not really done much on how to really extract that in the visualization itself, like to get an idea automatically how much the user knows. But we have been looking into doing something like guided tours through the visualization that can help those who are not familiar. And maybe if we actually could gather feedback there, that would help to switch between different levels of extraction, those suited maybe more for model developers and those who just want to use a model and want to see why it predicts a certain way.
Okay. Okay, great. Well, great presentation, and we can continue this discussion on the Discord.
Thank you.
All right, hello everyone. I'm Sean McKenna. I'm here to talk briefly about our poster session coming up in just a little while. For those not aware, you can get to our posters on iPosters. The link is on the virtual Viz site. I'll post all this information in the Discord as well. There's a filter to look at just the VizSec posters there. And there's also a channel that I'll have links for. You can click to get to the interactive sort of text space for each of the authors, but then there's also an audio channel. So be sure to hop in there, check out the posters, and also just the broad Viz posters too, all available to everyone here, and super great content this year. So I'd highly recommend everyone to check it out. And also want to give a shout out to our best posters committee. I had both Nicola and Rosa helping out with that this year, and we are excited to announce our best poster award for the Arcus Internet Disruption Dashboard and Report by Violet Lingenfelter and Robert Gove and Shay Clark and Anthony C. Wong. So again, great work this year, awesome posters, and look forward to seeing you all there.
So hello again. I'm doing a few closing remarks at the end of a great VizSec 2020, I think. And as I found out in the morning when I did the opening session, I still want to show you some slides that were kind of blanked out during my presentation. So and these slides are important to me since I definitely wanted to thank the organizing committee properly. And now that you've seen almost every one of our organizing committee, you can also link the faces to what you've experienced today. So once again, thank you to the program co-chairs Marco Angelini from the University of Rome and Chris Bryan from Arizona State, our two program co-chairs who developed the entire program, the publication chair, Rosa Romero Gomez from Uncharted, who did a great job in getting everything, all the publications at IEEE. Sean McKenna from our poster chair this year, thank you very much, from Lucid Software Incorporated. Everything you saw on the web comes from, was done by Evelyn Sopan from Sophos. Thank you for that. And our publicity chair, Nicolas Prigent from LSTI in France, who did all the Twitter messages and the emails that went out. So you didn't also see the steering committee this morning. Many thanks also to our steering committee in the background and handing out a helping hand whenever we needed it. And the program committee who helped very much with all the papers, the reviews, and getting the groundwork for a great program today. So, and especially thank you to all the authors, all the presenters today, the session chairs who helped with the question and answers and everything, and especially the technical support by IEEE Viz and the guys in Salt Lake City. Thank you so much. I think it went very smoothly. Thank you once more for that. Finally, well, VizSec 2021 will definitely happen. It will be maybe in New Orleans, Louisiana. But if it will not be virtual, it will be in New Orleans. Most likely, or maybe it will be virtual or hybrid or something else that we haven't found out yet. The general chair for next year will definitely be Marco Angelini from Sapienza University of Rome. And please stay tuned on VizSec.org. Follow us on Twitter to find out about the call for papers. I think we've seen great papers today, and we hope to see that again next year. And thank you everyone once more, and see you hopefully next year and a little bit more this week. So bye-bye and thank you.
Urban motion, illustrating the movement of population from billions of sparse trajectory records. Chang'an Avenue correlates with movement flow, the regions with the largest flow volume. Zoom into the region. The southern Huilongguan region is mostly in blue, cut by G6, which could account for its commuting issue. Rainstorm in Beijing, movement speed is much higher on average. At the remote regions of Beijing, there are few local movements.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
In our talk, we will introduce a didactic methodology for crafting interactive visualizations. This methodology uses a construction kit that describes a visualization using a set of building blocks. Our approach contains 3 successive steps that can assist students and anyone interested in crafting, ranking, and improving new visualization ideas.
Many real-world analysis environments involve multiple types of experts and analysts working together. We aim to provide new knowledge about the role of provenance in a variety of data analysis scenarios. We present the findings from interviews with the data analysts from various domains. Our results demonstrate how different needs for provenance depend on different analyst roles and also helps to identify possible opportunities for advancements and new techniques for provenance support.
We present an exploration into co-located collaborative immersive analytics in a prototype called Fiesta, the free-roaming immersive environment to support team-based analysis. The prototype allows groups of users to visualize and explore their data in a room-scale environment, which we used in an exploratory study involving 10 groups of 3 participants. We focus on the roles which 2D surfaces have, as well as how users leverage the 3D space during both the individual and collaborative work.
DataBreeze is a multimodal visualization system that lets people interact with unit visualizations using pen, touch, and speech. By supporting multimodal interaction, allowing users to manipulate, refine, and customize the view, DataBreeze enables a novel, fluid, and flexible data exploration experience, enabling a seamless transition between global and local level data exploration, spanning the entire dataset or a subset of the data.
Data journalists are a compelling group through which to study data wrangling because they frequently publish their methods to sites such as GitHub. In Table Scraps, we perform a qualitative study of their codes and computational notebooks to better understand the needs and pain points of journalists while data wrangling. From this data, we produce 2 taxonomies of computational journalism and a framework for multi-table data wrangling, and demonstrate these contributions through 2 case studies.
Our paper describes the motivation, ideation, and prototyping of a novel visualization tool to support voice training for transgender people. We centered our design around user needs and lived experiences, in order to support self-determination of gender expression. In so doing, we make novel inroads in how to visualize speech data and open possibilities for future work in the design of visualizations that prioritize user agency.
As word clouds grow bigger and words get pushed into the periphery, viewers are less able to accurately compare data, font size for example, associated with each word. This indicates that large distances between words detract from a reader's ability to extract data from the word cloud, but that this bias goes away with longer periods of reader perusal, suggesting perusal time being an important consideration for design.
Table cartograms are a recent form of data visualization that embed tabular data in a grid of quadrilaterals, like a heat map that has been areaed rather than colored. There are lots of different valid outputs for a single input table. Unfortunately, algorithms found in prior work prevent exploration of this design space. We present a web-ready algorithm for creating table cartograms using an optimization-based approach that supports a wide variety of outputs and aesthetics. Find out more at this address or come by our poster.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
With cluttered or noisy line charts, analysis tasks become difficult, for example selecting the most significant peaks in this data. To overcome this, we can turn to data smoothing. However, many methods are available, and while their results look similar, each preserves different properties of the data. We present a framework for measuring the effectiveness of smoothing techniques on 8 different low-level tasks, and our findings summarize the effectiveness of 12 different smoothing techniques.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Urban traffic congestion has become an important problem. Previous studies have focused on detecting traffic congestion and predicting future trends. However, it is difficult to find research that identifies the causes of traffic congestion. In this paper, we propose a technique to analyze the cause of traffic congestion based on the traffic flow theory.
We present VRIA, a web-based framework for creating immersive analytics experiences in VR, built upon popular web technologies and enabling the implementation of VR experiences in a web browser, accessible on many platforms. VRIA offers a visualization creation workflow for different levels of expertise using a bespoke builder tool, a declarative grammar, and an API for extensibility. We present a series of use cases along with considerations on performance, scalability, and lessons learned. See you in our talk.
Uncovering causal relations in event sequences can benefit decision-making in various applications. We present an interactive visual analytics system, Sequazzle. It incorporates an algorithm with a user feedback mechanism for learning causality in event sequences under the supervision of human experts. It also provides a set of visualizations to support causal exploration, verification, and comparison.
we present Uplift, a system that supports casual collaborative visual analytics in the domain of smart grid technologies. We applied a co-design approach to design, implement, and evaluate Uplift with experts in energy systems and members of the Monash microgrid project. Uplift uses embedded data visualization to show energy data for each campus building.
To uncover football tactics, we create spaces and times. We use time query, construct spaces, construct times. Our approach was used for reconstructing team tactics in different classes of game situation. Our domain experts are happy, and the Germans shall win again and again.
Typically, black hole visualization takes a lot of compute time, but we achieve a quite faithful reproduction at interactive rates on a standard computer. For this, we make use of a novel adaptive grid approach to focus calculations where needed. Coupled with filtering and interpolation methods, we can obtain high-quality imagery. Our approach accepts star catalogs and environment maps and generates the resulting deformations in real time.
In our work, we look at how narratives and gamification can be used to foster development of visualization literacy skills in young children between 11 to 13. We present our own instance of such a game, evaluate it in a between-subject study, and report results. We also detail key design considerations for future visualization-based games and highlight many opportunities for future work.
Studies in HCI follow similar steps in explaining hypotheses, laying out a study setup, and reporting results. Many of these decisions are buried in dense scientific text. We contribute a set of examples of how data comics support that reporting, providing an initial set of concrete ideas for how to communicate common stages of HCI studies and statistical analysis.
What is insight? It is a question that has bothered visualization researchers for a long time. We're wondering whether visualization practitioners think about data insights in the same way as visualization researchers do. So we interviewed 23 visualization practitioners to understand how they think. To find out more about what we found and the implications to the visualization community, take a look at our paper.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Usual collaborative systems propose a public and private environments, the latest possessing visibility rights. Subjective views are special objects perceived differently per user. However, a break in the social space may happen during exploration. Our visualization context strives to link efficiently multiple related visualizations together around a common object. We discussed about the designs of a stacking layout, virtual linking layout, and a mix between them.
We propose a localized approach to topological simplification called LTS, which computes the exact same result as the current state-of-the-art simplification procedure implemented in the topology toolkit. But LTS is an order of magnitude faster as it utilizes shared memory parallelism and constrains computationally expensive procedures onto small subsets of the domain. This approach significantly accelerates an essential part of topological data analysis pipelines.
Typical e-ink displays are in black and white. With the absence of color, we explored texture encoding as an effective way to visualize data. Inspired by existing practice, we summarized black and white texture properties, which can be used to encode data. We developed a prototype of a design tool that can customize black and white textures by manipulating these properties.
In this work, we present an atmospheric model tailored for the interactive visualization of planetary surfaces. Our model provides a complete framework for the absorption of light by small and large particles, such as the oxygen and ozone molecules and Mars dust particles. We demonstrate our results using Earth and Mars as examples.
Ensuring the usability of a dataset is often tied to data wrangling. We can use provenance to log the employed steps, but these alone will not give us meaningful insights if data quality was improved. We propose to incorporate data quality metrics into the provenance model. The enhanced provenance graph can be visualized to show the development of quality throughout the wrangling process. To find out more about the visualization design and the results of our evaluation, please join us during the live presentation and discussion session.
Rendering large volumetric datasets is still a challenge for real-time applications. Wouldn't it be nice if you could just render the dataset at a low screen resolution and your neural network upscales it to the full resolution again? We proposed a network architecture that does exactly that and can outperform a full resolution rendering for large datasets. For quantitative and qualitative evaluations, come to our talk.
Hey everyone, I'm Junhan Chao, PhD candidate at Purdue University, computer graphics major. I'm presenting our recent research outcome, Fink's Map, an abstract approach to visualize 2D spatial distributions. Due to the conflicts between the limitation of display area and the large amount of comparative distributions need to visualize, the current methods are always restricted. These observations encourage us to come up with a solution by abstracting the visualization.
As visualizations begin to use color, shape, line, and form in new ways, legends often go overlooked as essential to interpretation. To address this issue, we created a web-based interface that renders and formats legend entries, presenting the dynamic properties of glyphs, lines, and surfaces, and increasing nuanced object recognition in artist-driven 3D scientific visualizations. Each legend entry includes the variable name, full value range, and artist-chosen artifact.
Researchers use Argus to determine the sample size based on estimations. There exists a non-trivial dynamic relationship between those estimations and the statistical result and power. Argus allows researchers to explore scenarios of experiment design and effect sizes to better plan experiments.
Atmospheric convection is one of the most important phenomena in meteorology. It is responsible for cloud formation and storms. Yet, the measurements of the convective processes are expensive and scarce. In Isotrotter, we collaborate with a domain expert to build an empirical model of the atmospheric convection based on paragliding data. We design a novel visual parameter space analysis technique using isostructures in the parameter space to explain and validate the model.
Large displays are beneficial for visualizing vast amounts of data. However, there are challenges regarding perception, personalized views, and managing data complexity. To address these issues, we propose to combine large interactive displays with personal augmented reality. We present a design space, as well as several visualization techniques, such as curving the whole screen, embedded visualizations, and many more.
Hi, please come see our talk if you are curious about how to encode your data so that it can be efficiently queried later at different fidelity levels by fetching only the relevant bits from the disk. The talk is titled Efficient and Flexible Hierarchical Data Layouts for a Unified Encoding of Scalar Field Precision and Resolution.
To generate a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting. To lower the technique barrier, we introduce an intelligent system, Calliope, to generate visual data stories directly from an input spreadsheet in a fully automatic process. Using Calliope, a good visual data story is just a click away from us.
Nowadays, technology is developed for a single audience, assuming that one size fits all. Nevertheless, we all have individual differences, such as personality. Taking into account how personality affects preferences, we study whether it has an effect on hierarchy, evolution over time, and comparison context regarding information visualization. We leverage all personality variables from the 5-factor model and the locus of control with correlation and clustering approaches, showing promising results.
Approximately 100,000 cases of head and neck cancer are diagnosed in the US annually. Patients are increasingly likely to survive but often experience acute and long-term side effects. Hence, great importance has been placed on improving patients' quality of life and reducing symptom burden during treatment. Using novel visual encodings, we introduce an interactive system which enables clinicians to assess medical data, providing context for new patients based on clinical features and symptom evolution over time.
We present an investigation into design judgment in data viz practice. Our findings show how different types of judgments influence design decision-making. Our findings also show that judgments occur in complex and layered ways while designers move through their process. We discuss implications for future research and pedagogy.
Dimensionality reduction is an important tool for the visual exploration of complex high-dimensional data. Most existing techniques focus on preserving the intrinsic geometry of the data during the projection. However, important information can be encoded within the global structure of the data. To address this, we present TopoMap, a dimensionality reduction method that provably preserves the topological features of the data during the projection.
This work presents a detailed account of an attempt to explain tightly coupled relationships through storytelling and animation in a multi-user, informal learning environment to a public with varying prior knowledge on the domain and identifies lessons for future design. It offers qualitative empirical findings with particular emphasis on how, despite careful design, visitors may walk away with little knowledge about the data and the problem.
The blood vessel structure on the human placenta can be an important indicator in the detection of birth complications, but the segmentation of the vasculature tree remains a challenging problem. In our work, we show how MRI visualizations in immersive virtual reality can help medical practitioners to identify blood vessels without the need for a contrast agent. We present the results of a user study and lessons we learned for vasculature exploration in VR.
We propose V2V, a comprehensive pipeline for variable selection and translation for multivariate time-varying data. Our approach contains feature learning, translation graph construction, and variable selection. To demonstrate the effectiveness of our approach, we compare histogram matching, pixel to pixel, and cycleGAN to evaluate variable translation. In addition, we also compare an information-aware framework to evaluate variable selection.
Hi, everyone. It is a work about graph visualization. With one node link diagram, dragging node can change the layout of the diagram as you like. But how about more diagrams? Dragging nodes can be laborious. Please come to our talk about exemplar-based layout fine-tuning for node link diagrams. We will give you our ideas.
Generating a stacking ensemble of models is usually a complicated trial and error process. In order to deliver the best and most diverse stacks to the user, we propose StackzenVis, a visual analytics system that supports an iterative process. With different algorithms and quality metrics, instance and feature selection, model optimization, and more.
We conducted semi-structured interviews with 20 data viz practitioners to investigate how they understand chart junk and the factors that influence how they use it in their design work. Our findings suggest a number of themes about each topic. We highlight the personal and situated nature of how practitioners understand and make use of concepts, and argue for more practice-led research within Viz.
Hi, my name is Sarah. In my talk, I'm going to be presenting a visualization to display an overview of multiple sequences of events and attributes. The key feature of our visualization is how easy it makes spotting trends and patterns in the data. You can find more info in the links on the right. Thank you.
This study presents a method to explore hierarchical data by improving RODViz, one of the visualization techniques for multidimensional data. The user can set options for nodes and check the data in groups or individually in the RODViz. 3 subviews at the right enable the hierarchical clustering structures of selected data and allow the user to grasp the features of selected data. As a result, this system allows more detailed insight into the data while solving the node overlapping problem.
How do people really make use of space to spatially organize their ideas? To answer that, we collected 280 images from the web, which came up by searching keywords such as brainstorming. And we found spatial organization patterns and interesting observations about how people make use of space.
The most impactful and effective visualizations through history are often visually complex, thought-provoking, and not amenable to quick glances of information. Yet, in our teaching, our experiments, and our textbooks, we often advise people that the most effective visualizations are those where we get information as quickly as possible, like in scatter plots. Why this disconnect? Why aren't all visualizations scatter plots?
The recent technological advancements in mixed reality extend our ability to evaluate new visualizations faster than ever before. In a user study with 60 participants, we compared 4 situated visualizations using 5 different empirical methods. In contrast to prior work, our results showed no dependency between the user's feedback and the empirical methods.
Kirigami is a rich, complex Japanese tradition of paper cutting. We leverage kirigami to create new physical data representation and simple interaction. This is an example which shows global warming in 5 countries. The expansion shows mean temperature in each country in 1962. The user can manipulate the model by adding measure weights, and the increased expansion shows the mean temperature in 2012.
Modern agile developers use a variety of tools and systems to build better code, but none are more important than the automation servers that tie these complex pipelines together. The Jenkins Pipeline Visualization is a mobile application for Jenkins automation servers that gives users rich insights into their code state in the software development lifecycle.
Hello,
we are presenting deep volumetric ambient occlusion, a novel technique for deep learning-based ambient occlusion in volume rendering. In our talk, we're going to discuss three things. First of all, volume-to-volume learning in general. Second, how you would combine unstructured information with 3D CNNs. And lastly, what you can take away from our work for volume learning in general. See you there.
Today, there is a pressing need to extract and visualize sophisticated 3D structures from raw volumes without tedious manual parameter tuning and handcrafted features. Well, our VCNet, a data-driven neural network, builds a new paradigm to combine 3D volume processing and volume rendering clue that can segment and visualize challenging 3D macrovasculature systems in real time. Thank you.
In visual analytics tools, provenance is used to capture activities on different levels of granularity. However, current approaches do not support inferring tasks spanning across these levels. We propose a framework for inferring user tasks from provenance involving three stages: initializing, parsing, and leveraging. We will present a use case to show the roles of context, variability, and iterative refinement. Join us further discussing our agenda and the challenges of implementing such a framework.
Functional safety analysis is an automotive systems engineering technique that helps minimize unreasonable risks associated with automotive electronic and electrical systems. We developed a visual analysis tool, Safety Lens, to assist domain experts to perform exploratory analysis of a single project as well as comparative analysis among multiple projects.
We propose a method palettailor that fully automates the coloring process of categorical data and produces discriminable results. Based on both color and data spaces, our method incorporates three scoring functions into a customized simulated annealing algorithm. We apply our method to different types of visualizations and compare it with the state-of-the-art palettes through a controlled user study.
The make of continuous color maps. We present the CCC tool, a new web tool for the creation, editing and analyzing of application-specific color maps. For the precise definition of color maps, we developed a new color map specification. This new structure increases the editability by reducing the numbers of colors to a minimum.
We study the limitations of node-link diagrams with respect to pathfinding tasks. But wait, I hear you say, hasn't that been studied before? Actually no, path studies typically measure only accuracy and time for fixed network sizes. We used a number of physiological measures including brain activity and looked at a range of network sizes and densities. We discovered that the threshold for difficulty is much lower than expected. This talk is essential viewing for anyone interested in network visualization design.
Although prior work has examined how visualization impacts decision-making, there is no concrete method for quantifying and comparing the impact of different encodings on decisions. We rethink how we evaluate decision-making with visualizations by leveraging work from economic theory. We present the results of a large-scale lottery game that evaluates the impact of 5 different visualization designs on risk behavior and decision-making.
We propose a novel visual analytics system for optimizing bus networks. The system helps users first analyze bus network performance and identify problematic routes. Then, the alternative to a selected routes can be obtained in real time. By evaluating these routes with our system, the users can efficiently decide which one is the best and improve the bus network.
This project looked at charts submitted by U.S. public companies in annual 10K reports. The most common chart types were identified, and the more unusual types tested in an experiment. Participants were unsuccessful with scatter or relative waterfall charts, but successful with stacked bar and combo charts. Several design flaws were identified and verified experimentally. Overall, the study shows the need to improve financial chart design.
University directories routinely become outdated and often lack the information necessary for understanding a researcher's interests and past work. To assist in the exploration of research talent, we have designed PeopleMap, an interactive tool that maps out researchers using NLP techniques. By using PeopleMap, users can explore the diversity of research at an institution and identify potential research talents.
Existing visualization tools for deep learning classification are mostly working on natural images with mutually exclusive classes. The classification of X-ray scattering images is more challenging since their multiple structural attributes have complex relationships. So we built an effective visualization system to study the model performance and to find questionable labels or outlier images for scientists' further improvement.
When building the hierarchy for big data, different users may require different hierarchies to meet their diverse needs. However, existing one-size-fits-all methods often fail to meet the diverse needs. To tackle this issue, we present an iterative steering method to visually supervise the constrained hierarchical clustering by utilizing both public knowledge from knowledge base and private knowledge from users.
Visual data analysis of large amounts of data demanded solution which provides users the means to enter into the dialogue with the information visualization. To understand how multimodal interaction using touch, speech, and middle hand gestures can tackle this gap, we conducted an explorative interaction elicitation study. We argue that users are highly receptive to use multimodal interaction for visual data analysis and that especially the combination of touch and speech would be promising due to their complementary nature.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Virtualizations don't have to be static. In fact, sometimes it is the visualization that is static, but the viewer is moving. And sometimes both of them move. We present a first design space of visualizations in motion, an implementation of this design space, and we are working on a user study.
We present a suggestive interface for untangling mathematical knots with complicated structures. Our interface can help users deform knots with the right sequence of mathematically legal moves. It allows one to sketch and untangle knots by proposing the right method moves. If interested, welcome to our presentation.
Hi, everyone. It is a work about graph visualization. With one node link diagram, dragging node can change the layout of the diagram as you like. But how about more diagrams? Dragging nodes can be laborious. Please come to our talk about exemplar-based layout fine-tuning for node link diagrams. We will give you our ideas.
Determining the veracity of a factual claim made by public figures has become a common task for journalists. However, fact-checkers face critical challenges as they try to sweep through a long transcript to verify claims. We present ClaimVis,
a visual analytic system that supports the journalists to identify and verify claims from a transcript.
Over hundreds of tools exist for visualizing genomics data, leaving the analysts with a large design space to analyze before finalizing the visualization. We present a data and task-based recommendation system. The recommendation system uses a sequential model to suggest appropriate visualizations to users. To learn more about our recommendation methodology and results, please visit our poster.
In interdisciplinary visualization research, scholars browse collections of scientific papers, searching for existing methodologies that can be imported into their own domains. In this short paper, we implement a document exploration prototype that employs distribution and similarity between author-assigned keywords to detect potential methodology transfers between two collections of research papers. If you want to know more, please read our paper.
We propose a data reduction pipeline for steady vector field data using deep learning techniques. Our approach consists of low-resolution initialization and high-resolution refinement. Our approach can evaluate the quality representative streamline selection algorithm. In addition, we also compare our approach against gradient vector flow and lossy compression.
We present three external labeling concepts that allow a user to browse through point sets without the need of zooming in and out. In the first method, labels are distributed on multiple pages. The next method arranges the labels in a single row that can be continuously slid along the bottom side of the map. In our third method, labels are distributed on stacks, which a user can independently browse through.
MeetQueues is an interactive visual platform which augments existing tools for meetings with features that help people engage and reflect. Its visualization shows if more people are satisfied or uncertain about the contents of a meeting. Attendees can add comments and upvote others' comments. Attendees can reflect on the contents and what happened during the meeting using the summary page sent after it is over.
Providing insights is the main purpose of visualization. A lot of systems automatically communicate insights to users, but we don't really understand a lot about the space of these automated insight tools. We conducted a review of 20 automated insight tools and proposed a framework of the types of automated insights and the purposes of providing auto insights. Take a look at our paper to learn more.
When NASA engineers plan a mission, they turn to space trajectory designers to chart a path that minimizes the need for popular mass. In this work, we applied a topological analysis of the circular restricted three-body problem to space trajectory design, and demonstrate the benefit of this approach to devise compelling solutions to realistic trajectory design problems.
The search for high prevalence of crimes ends up neglecting sites where certain types of crimes are frequent but not sufficiently intense to be considered statistically significant. In this paper, we proposed a technique centered on NMF to identify hotspots based not only on the intensity but also on the frequency. We introduced a visual analytic tool to support the domain expert in their analysis, whose usefulness of the system are highlighted by comparisons and case studies with real data.
Mode surfaces are the generalization of degenerate curves and neutral surfaces,
In this paper, we provide novel analysis on the topological structures of mode surfaces. This allows us to not only better understand the structures in mode surfaces and their interactions with degenerate curves and neutral surfaces, but also develop an efficient algorithm to seamlessly extract mode surfaces. We apply our analysis and visualization to a number of solid mechanics data sets.
Comparative layout are the visualization arrangement to support visual comparison tasks. To better understand them, we conducted a systemic survey on 127 research papers. Based on the survey, we suggest a lucid classification, as well as diverse practical implications that help you better design comparative visualizations. Find out more in our presentation.
We present responsive matrix cells, a focus on context approach for exploring and editing multivariate graphs. For a matrix visualization encoding both adjacency and node similarity, we propose to embed responsive visualizations in these cells. These visualizations can not only detail the aggregated value of a single cell, but also represent multivariate or structural aspects for a group of cells and even allow for editing values.
Machine learning advanced state-of-the-art in many fields. However, for Vis, it has just begun recently, partially due to the lack of training data. To spur data-driven research in Vis, we simulated and released a 16 terabyte dataset containing 8,000 unsteady 2D vector fields.